My dear my dear students, this is my first experience communicating to you in this manner. At least you will see me that I am with you all, in this very crucial time for we class 12 students, because already we have spent a couple of months without coming face to face. Teachers and students need to interact face to face. Anyway, whatsoever facilities are available according to that, we are coming up. All the 4 chapters we have taught you: solid state solution, electrochemistry, and chemical kinetics. A very comprehensive notes I have given you. You need to browse through it. Sometimes some visibility problem, if you notice, zoom it, make it comfortable, and prepare your own notes after browsing through my notes. Anyway, dear children, good morning to all of you. See, the topic is surface chemistry. This surface chemistry is the branch of physical chemistry which deals with surface phenomena. Surface phenomena. Surface chemistry deals with surface chemistry deals with surface phenomena. You know, if this be the container, so this boundary, this is the surface, this is the surface, this is the surface, and suppose this is the surface. So you know, there are substances, the concentration of which is noticed very large on the surface of a substance. This is the substance. Okay. This is what we call adsorbent. Adsorbent. Suppose this adsorbent is A, denoted by A. And suppose some gas molecules are stuck on its surface. These gas molecules, we are naming it B. So this B is adsorbate. B is adsorbate. So what happens? Adsorbate is adsorbed. Adsorbate is adsorbed onto the surface of adsorbent. Is it clear? So this is the issue. The main issue in adsorption, the main issue in surface chemistry is adsorption. 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 Okay. So what is adsorption? Adsorption is a phenomenon in which there is a larger concentration of a substance on the surface of another substance compared to the bulk. We are not interested whether those molecules are also present to some extent in the bulk. We are mainly interested if those molecules, those foreign substances, those gaseous molecules are present on the surface or not. If there be larger concentration of a substance on the surface, the phenomenon is on the surface of a substance, the phenomenon is adsorption. So adsorption is a phenomenon in which there is a larger concentration of a substance on the surface of another substance. Dear students, check the definition. Adsorption is a phenomenon in which there is a larger concentration of a substance on the surface of another substance. So, the example is here. This is suppose the surface of a substance. This substance is providing its surface, therefore this is called adsorbent. This is adsorbent. And suppose these gaseous molecules are accumulating onto the surface of this substance. These gaseous molecules we are denoted simply by B. Therefore, this B, what we call adsorbent, is being adsorbed onto the surface of adsorbent. So clear? I think adsorption is clear. One example, very important. This is the example. One example I will give you. Suppose this is evacuated apparatus. Gaseous pressure is low. What I mean, most of the air has been removed. And suppose this is this container, this apparatus is connected to another container containing charcoal, cooled, very cooled. So in this another container we have charcoal in a very cool state. Then what we see that after some times, the remaining air molecules, the remaining gaseous molecules are adsorbed. The remaining gaseous molecules of this evacuated apparatus is adsorbed on the surface of charcoal. This is how we can create a vacuum. This apparatus, the condition here is that we may have certain gas molecules here in this chamber, in this apparatus. Now those gaseous molecules are being adsorbed by this charcoal, which is a very good example of adsorbent. And as a result, what is happening? A vacuum is being created. Okay, this is one example. Another example, suppose we have a sugar solution that is colored due to certain kind of impurities. This is impure sugar solution. We want to remove those impurities from the sugar solution. If sugar solution is passed on pieces of charcoal, what happens? Colors and other impurities are adsorbed on the surface of charcoal. As a result, what happens? This sugar is purified. Now we are left with pure sugar solution. Okay, so there are several examples. There are several examples, very famous in this connection. I will tell you that there are a number of transition metals, D block metals like palladium, platinum, copper, nickel, other substances also. Other substances, I mean transition metals, or their oxides. For example, chromium 3 oxide, as I have told you in my audio clip also. The same thing I am telling you. Only thing is that you can see my face and some blackboard work you can see here. Okay, so Cr2O3, chromium sesquioxide, Cr2O3. This is chromium 3 oxide, also known as chromium sesquioxide or zinc oxide. These are also very good adsorbent. They adsorb gaseous adsorbates. Another example, you know that nickel is very famous for adsorption of hydrogen gas. Hydrogen gas very easily gets adsorbed onto the surface of nickel, though it is not a good adsorbent for nitrogen gas. It is therefore, it may be a specific. It may be a specific. Whether a particular adsorbent will adsorb on the adsorbent or not, we have to take into account the nature of adsorbent, and of course, large surface area of adsorbent. Okay, very popular example. Another example, suppose when we didn't have this whiteboard and this pen, what we write with on this board, we made use of chalk pieces, chalk, pencil. Suppose that pencil, chalk, is immersed into an ink solution. Ink solution, okay, let it be blue colored. And after some time, if we take out that pencil from that ink solution and break it into two parts, what happens, you will notice that colors are concentrated on the surface, and if you take care of its bulk, if you look into it, you find that no color is adhering in the bulk. This is the example of adsorption. Clear? Now that a parallel phenomenon in this connection is absorption. A parallel phenomenon is absorption. In absorption, you will notice uniform penetration of a substance throughout the another substance. For example, this is anhydrous calcium chloride. And here, this is water vapor. After some time, what you find that suppose you are having this anhydrous calcium chloride in a container. After some time, you will notice that we have now the aqueous solution of solution of CaCl2. CaCl2. What happens? This water vapor is uniformly assimilated into the entire bulk of anhydrous calcium chloride. There is uniform concentration of water vapor in anhydrous calcium chloride. It is not stuck at the surface only. This is a bulk phenomenon, and what we call this, that is absorption. That is absorption. This is absorption. This is absorption. So in absorption we are interested that there should be uniform concentration of a substance throughout the bulk of the substance. Then we call it absorption, and if there be larger concentration of a substance on the surface of another substance, then that is adsorption. This is a minor difference between absorption and adsorption. Now that we have understood something about absorption and absorption, we can always, the main issue in this chapter is adsorption, because this is a surface phenomenon, and subject matter of surface chemistry is adsorption. So see, delta H adsorption is always negative. Delta H adsorption is always negative. One thing is clear, we have noticed that with increase in temperature, extent of adsorption decreases. With increase of temperature, extent of adsorption decreases. That means adsorption is certainly an exothermic process. On the basis of our findings that with increase in temperature, extent of adsorption decreases. Okay, with increase in temperature, extent of adsorption decreases. That means adsorption is an exothermic process. Okay, lastly I am telling you, don't get confused. The process of adsorption is exothermic in nature. We are telling this because this has been noticed that with increase in temperature, extent of adsorption decreases. Okay, based on this, another thing, thermodynamically we have a very famous equation, delta G is equal to delta H minus T delta S. Check. We are considering that adsorption is taking place. That means delta G is negative because adsorption is taking place. Okay. In order that adsorption takes place, delta G has to be negative. Now consider delta S, that is change in entropy. You know, suppose this is the surface, and here gaseous molecules are adsorbed. So what happens here? Gaseous molecules before adsorption were having greater degree of freedoms to move about the available spaces. But after adsorption, what happens? Its degree of freedom, its randomness is decreasing. Its randomness decreases. The moment randomness decreases, that means delta S is negative. So once this is negative, delta S is negative, so T into delta S is negative. Negative into this negative is positive. So this factor is positive. Minus T delta S is positive, and delta G has to be negative. This is only possible when delta H is negative. Therefore concluded that adsorption is an exothermic process. Okay. Now, in this connection, so we are clear about the term adsorption. Larger concentration of a substance on the surface of another substance is adsorption, and absorption is throughout the same concentration of a substance in another substance. Okay, that is absorption. So absorption is a bulk phenomenon, while adsorption is a surface phenomenon. Okay, adsorbent is the a substance which provides its large surface area for adsorption, and adsorbent is the substance which is adsorbed onto the surface of adsorbent. Is it clear? So many examples we have given you on for adsorbents. So many metals, transition metals, platinum, platinum, okay, palladium, copper, nickel, other even iron also. Even iron also, molybdenum also. So many other examples are also there. Even transition metal oxides like chromium 3 oxide, chromium sp oxide, they are all very good adsorbents. Charcoal being very porous has larger surface area. Therefore, this is also a very good adsorbent. Silica gel is also a very good adsorbent. Silica gel, you know what is silica gel? This is made from silicic acid. If silicic acid, that is H2SiO3, H2SiO3, silicic acid is partially dried, okay, partially dried. So gelatinous silicic acid, if partially dried, becomes silica gel, and this is a very good adsorbent. Okay, it provides its surface for adsorption. These things are over. We have explained why change in enthalpy for adsorption is negative. Okay, that is adsorption is exothermic process. Okay, now two things are there. Types of this is types of adsorption. Types of adsorption. There are two types of adsorption. One is what is called physisorption. Physisorption. Another is what is called chemisorption. Chemisorption. So here physisorption, that means physical adsorption. Chemisorption, that means chemical adsorption. Again, listen carefully. Physisorption is physical adsorption, and chemisorption is chemical adsorption. This is also known as activated adsorption, and this is van der Waal adsorption. Or here force between the adsorbent and adsorbent is weak. Van der Waal force. Here force between the adsorbent and adsorbent is comparable to chemical force, to chemical bond. Chemical bond. So no compound is formed when adsorbent gets adsorbed on the adsorbent in case of physisorption, because force of attraction is very weak. While in this case, chemisorption, force between the adsorbent and adsorbent is comparable to chemical bond. Therefore, compound formation may take place because force is comparable to chemical bond. So there is chemical bonding between the molecules of adsorbate and adsorbent in case of chemisorption. Another thing, the activated adsorption. We have named it activated adsorption also because once this is a kind of chemical reaction, chemical bonding takes place between adsorbate and adsorbent. Therefore, this chemical adsorption requires activation energy. Activation energy, like any chemical reaction, chemical reaction requires activation energy to take place. In the same way, chemisorption also requires activation energy to take place, hence the name activated adsorption also. So many things are there, important points. Physisorption is non-specific. Okay, physisorption may take place on any surface, any suitable adsorbate may be physi-adsorbed on a particular substance, any particular, no need of particular substance. Particular substance, if adsorbed on a particular surface, then that kind of adsorption is chemisorption. Therefore, chemisorption is specific, and this is non-specific. Non-specific because for physisorption, no need to specify that what kind of adsorbate and adsorbent should be there. Physisorption, if the substance has higher surface area, large effective area, okay, and other conditions are fulfilled. Certainly low temperature condition, and high pressure condition will come across later. Then physisorption takes place. This is not specific, but chemisorption is specific. Adsorption, this kind of adsorption, chemisorption can take place only when there is a possibility of bond formation between the adsorbate and adsorbent molecules. So one point. Another is physisorption is multi-layered. This is like some kind of Mandel love. Okay, Mandel love. What I am telling you, for example, one person is having relation with so many other persons. There is no specific kind of relationship between the particular two persons. Okay, so multi-molecular adsorption it is, and this is unimolecular. This is unimolecular. After chemical bond formation takes place between adsorbate and adsorbent molecules. Okay, adsorbate molecule is left with no residual force to bind another adsorbate molecule on its surface. Therefore, this chemisorption is unimolecular, while this physisorption is multimolecular. Another thing, another point is that low value for delta H adsorption here for physisorption, and this is 20 to 40 kilojoule per mole. 20 to 40 kilojoule per mole. This is delta H adsorption. Delta H adsorption for physisorption is 20 to 40 kilojoule per mole, while this is 40 to 200 kilojoule per mole. The reason is obvious here. Force of attraction between the adsorbate and adsorbent molecule for physisorption is very weak. Therefore, a less amount of heat energy is released to stabilize the system. So physisorption is a less stable process. This is a rather more stable process. Okay, larger amount of heat energy is released, and delta H adsorption is higher in case of chemisorption. These are some important differences between physisorption and chemisorption. This is once physisorption is reversible. Physisorption is reversible, but chemisorption is irreversible. Okay, this is like Indian marriage, man and wife. Okay, the relationship is permanent. They can be separated. They get separated, but by spirit they are one. By spirit they are one. That is chemisorption. What happens in chemisorption? This is irreversible chemisorption, and physisorption is reversible. Okay, now very quickly we will take up two important issues, and one is what we call adsorption isotherm. Adsorption isotherm. The moment I say, dear children, are you comfortable? I hope you are comfortable. I am repeating the thing so many times. Adsorption isotherm, first important thing that we are considering adsorption process, but the only thing is that temperature has to be kept constant. Temperature has to be kept constant, therefore the name adsorption isotherm. We can understand this, okay, this is x-axis, this is y-axis, and x by k e 1a. This is extent of adsorption, and this is pressure. And here temperature is constant. Temperature is constant. What is the extent of adsorption? First, be clear about it. X is the amount of the substance adsorbed. That is, X stands for adsorbate. X stands for adsorbate. Amount of the adsorbate adsorbed per unit mass of adsorbent. Per unit mass, this is M. Per unit mass of adsorbent. M stands for adsorbent, X for adsorbate. So mass of adsorbate adsorbed per unit mass of adsorbent is what we call extent of adsorption. This is pressure, temperature is kept constant. This is the curve obtained. This is known as friendly adsorption isotherm. Adsorption isotherm. Friendly gave a relationship like this: x by m is equal to k into p raised to the power 1 by n. That is, extent of adsorption, this simply says, is dependent on the pressure. So, variation of extent of adsorption with pressure at constant temperature we deal with under friendly adsorption isotherm. Okay, in this graph, in this curve graphical plot, you find that initially when pressure is low, this is 0, 0 origin. When pressure is low, x by m varies directly with pressure. X by m varies directly with pressure. Okay, x by m varies directly with pressure. That means case 1, low pressure condition. 1 by n is equal to 1. That means n is also equal to 1. That therefore x by m will be equal to k p raised to the power 1. That is direct variation of extent of adsorption with pressure. That means pressure increases, extent of adsorption also increases, provided that pressure is low. Okay. Next, case 2 we can discuss. Here writing case 2. Okay, case 2. case 1, case 2. Okay, this reason you find that written x by m equal to k into p raised to the power 1 by n. Here 1 by n is less than 1 but greater than 0. 1 by n is less than 1 but 1 by n is greater than 0. Moderate pressure. At moderate pressure condition. Okay, case 3, very quickly we are taking up case 3. After a certain pressure, okay, this is the pressure, I have written it PS, saturation pressure. Saturation pressure. You find that when pressure is saturated, that means when a particular point reaches, a particular point is reached in terms of pressure, at a particular pressure, okay, very clear. What happens? This curve becomes parallel to x-axis. This curve becomes parallel to x-axis. So this particular pressure is known as saturation pressure, and beyond this saturation pressure, what we see that extent of adsorption does not depend on pressure. This is independent of variation in pressure. Extent of adsorption doesn't depend on pressure. So that is case 3. That is case 3 at high pressure, at high pressure or very high pressure. What happens beyond another key point, beyond saturation pressure, that is beyond PS. In this case, x by m is equal to k p raised to the power 0 because 1 by n is equal to 0. Okay, that means extent of adsorption doesn't vary with pressure. Okay, so this is the nature of the curve obtained by Freundlich, and this is known as Freundlich isotherm. Isotherm because temperature is constant. You see here we have we have sketched two curves. This is at high temperature. This is at high temperature, and this is at low temperature. Low temperature. You find that direct variation of extent of adsorption with pressure is larger up to this pressure, here only up to this pressure, or you understand here up to this pressure, and here's so what happens at low temperature, extent of adsorption is larger. And okay, and this will be like this, This extent of adsorption is larger if temperature is made lower and lower. Okay, so extent of adsorption is larger at lower temperature. Okay, so these are the essence of this Freundlich adsorption isotherm. Okay, I have already provided you notes, shared audio clip also. Okay, and so you can kindly learn about Freundlich adsorption isotherm. And the last thing today we are taking up is that we have another important graphical plot that is known as adsorption isobar. Okay, adsorption isobar. The moment we have made use of isobar, that means pressure is being kept constant. So certainly the graph, we are studying the variation of x by m, that is extent of adsorption with temperature. With temperature and pressure is kept constant. Pressure is constant. So we have this kind of graph. This is for physics option. Very clear that at low temperature, here temperature is low. Is it clear here? At low temperature, extent of adsorption is larger. temperature increases, extent of adsorption decreases, temperature further increases, extent of adsorption falls, further decreases. So, lower the temperature, greater the extent of adsorption. This is explained by this adsorption isobar, provided that pressure is kept constant. That is important thing. Okay, you do not find any concept of activation energy here. There is no concept of activation energy. Therefore, adsorption isobar for Fiji-Jobson is different from that of Kemi-Jobson. In Kemi-Jobson, what happens exactly? Same thing, temperature on the x-axis and the extent of adsorption along the y-axis. And now here we have noticed this kind of graphical plot. Okay, this is what we call transition state or the summit of this curve or peak of this curve, and this is what is called activation energy. So certainly this is a kind of chemical bonding what takes place between adsorbate and adsorbent molecule. Therefore, adsorbate and adsorbent molecule require some activation energy. Then only adsorption takes place. So initially, with rise in temperature, this extent of adsorption keeps increasing. With rise in temperature, extent of adsorption in case of chemi-jobson, chemi-jobson keeps on increasing, reach its maximum value. Extent of adsorption becomes maximum at this temperature, at this high temperature, and after that, with rising temperature, this x by m decreases. With further rising temperature, extent of adsorption decreases, slopes down. As you notice, this curve slopes down after a certain temperature. Okay, so initially with rising temperature, extent of chemi-jobson increases, reaches a point where extent of adsorption is maximum, and beyond that temperature where the extent of adsorption is maximum, what happens? This extent of adsorption keeps decreasing. Okay, so this is adsorption isobar for chemi-jobson, and this is adsorption isobar. Graphical plots I mean for Fiji-Jobson. Okay, children, in this class, finally I am summarizing the class. You know, we have told at the very beginning that surface chemistry is about the property of surface. Okay, so surface phenomena we deal with in surface chemistry. The important term, the key issue is adsorption. Adsorption is a kind of interaction between the two substances, one being called adsorbate and another is adsorbent, in which there is larger concentration of one substance over the surface of another, that is adsorption. Contrary to this, absorption is a bulk phenomenon where there is the same concentration throughout the two substances mix up well. Okay, a uniform penetration of one substance into another is about absorption. Okay, one example I have given you, anhydrous calcium chloride. Okay, if kept exposed to air, what happens? Water vapor, it absorbs, and anhydrous calcium chloride comes into aqueous solution phase. Okay, while water vapors are coming down to calcium chloride, anhydrous calcium chloride, these dust particles may also settle down. This is why municipality people sometimes make use of this anhydrous calcium chloride. They sprinkle this chemical on the road so that air becomes clear for visibility, and particularly in coal fields, this is very common common finding that municipality people are sprinkling anhydrous calcium chloride on the road. Okay, clear? So charcoal, very porous, large surface area it has so many holes, minor holes. Therefore, what happens? A good deal of substance is adsorbed on its surface. Charcoal is a very good charcoal is a very good adsorbent. Okay, next summarizing. And the next thing is that we have discussed that chromium sesquioxide Cr2O3, okay, zinc oxide, palladium, platinum, copper, nickel, all that, all that are very good adsorbent. Okay, silica gel, another example. Okay, because they provide their large surface for adsorption. These are the things, so you can make a difference between absorption and adsorption. Second important thing, we have discussed that adsorption is an exothermic process. We have explained it in two ways. One thing is that with increase in temperature, extent of adsorption decreases. That means adsorption is an exothermic process. And another thing is that by thermodynamics, delta G is equal to delta H minus T delta S. Since adsorption has to take place, delta G change in Gibbs free energy must be negative, is negative, and delta S, because freedom of movement of adsorbate molecules decreases, it gets stuck on the surface. Therefore, delta S change in entropy is negative. As a result, minus T delta S is positive. So minus T delta S is positive on the one hand. On the other hand, delta G has to be negative. This is only possible when delta H is negative. So in two ways we can explain that this adsorption is an exothermic process. Delta H is negative. Okay, clear. Next, we have taken up the issues of this types of adsorption, physisorption and chemisorption. Physisorption, the only thing is that you have to understand that there is a weak force of attraction, that is van der Waals force between adsorbate and adsorbent molecule. This is a physical kind of interaction, therefore the name physical adsorption, or simply telling physisorption. Sometimes it is called as van der Waals adsorption. Okay, next is chemisorption. Here are the kind of force, okay, that exists between the adsorbate and adsorbent molecule is to the extent of chemical bonding. Hence, this is chemical adsorption, because any chemical reaction needs activation energy, and therefore chemisorption also needs activation energy, because there is chemical kind of interaction between adsorbate and adsorbent molecules. Therefore, chemisorption is also known as activated adsorption. Okay, so low delta H adsorption value for physisorption, because force is weak. As you know, van der Waals force is very weak, and chemisorption because kind of interaction is related to chemical bonding. Related to chemical bonding, the power of attraction between the adsorbent and adsorbate molecule is comparable to chemical bonding. Therefore, delta H adsorption is high. Okay, actual value we have given 20 to 40 kilojoule per mole for physisorption and 40 to 200 kilojoule per mole for chemisorption, that we have told you. Physisorption is not as specific, this is non-specific, but chemisorption is specific. Physisorption is multi-layered, but chemisorption is unilayered. Okay, no more residual force is left with adsorbate molecule to allow another adsorbate molecule to add on its surface. Okay, therefore chemisorption is unimolecular. That is okay. So these are few differences. Chemisorption is irreversible, because the kind of interaction is very strong. Okay, comparable to chemical force. Therefore, irreversible. Chemisorption is, physisorption is reversible. So these are the differences between the two phenomena, physisorption and chemisorption. And lastly, what I am telling you, that we have to discuss two important graphical plots. One is known as adsorption isotherm, another is known as adsorption isobar. Adsorption isotherm was given by Freundlich, and therefore sometimes it is also known as Freundlich's adsorption isotherm. What happens along x-axis we take pressure, and along y-axis we take XYM, that is extent of adsorption. So initially we notice that extent of adsorption varies directly with pressure. Linear variation is there, that is directly proportional. So XYM is therefore equal to K into P raised to the power 1. Okay, when the pressure is low. And another thing you notice that at moderate pressure, that is pressure is neither high neither low, in that condition x by m is equal to k into p raised to the power 1 by n. Here 1 by n is less than 1 or greater than 0. Okay, clear? And another important thing that you notice that beyond a certain pressure, when your curve becomes parallel to x-axis, and the pressure what we are talking about is saturation pressure. So beyond saturation pressure, what we notice that extent of adsorption does not depend on pressure. It is for that reason we have written x by m is equal to k into p raised to the power 0. What I want to say that 1 by n is equal to 0 here. Okay, so that is how we should study this Freundlich adsorption isotherm. By this Freundlich adsorption isotherm, one thing is clear, that with increase in temperature, extent of adsorption with increase in temperature, extent of adsorption decreases, and when temperature is low, extent of adsorption increases. Okay, these are all essential points related to Freundlich's adsorption isotherm, and that is over. And now we are coming to adsorption isobar. Again, along y-axis we have extent of adsorption, that is x by m, and temperature we have this time along x-axis, and pressure is kept constant, therefore the name isobar. Isobaric process is one. Isobaric process is one in which pressure remains constant. So name is isobar, pressure is constant, and the graphical plot you have to study between x by m and t. In case of Fiji option, you see the graph we have already expressed on the blackboard, or you will find that with increase in temperature, extent of adsorption decreases. Okay, and coming to Cambridge option, initially with increase in temperature, extent of adsorption keeps increasing, reach its maximum value at a particular temperature. Okay. And idea of activation energy has been incorporated because interaction between adsorbent and adsorbent is that of chemical nature. So after reaching the maximum extent of adsorption at a particular temperature, if you increase the temperature, if temperature becomes more, then what happens? This extent of adsorption keeps decreasing. So initially with increase in temperature, extent of adsorption increases, reaches its maximum, and beyond that temperature, when the extent of adsorption was maximum, what we notice is that extent of adsorption decreases. This is what happens in chemical adsorption, and that's all for today. Thank you. See you again.